So first write down the next example. Accordingly then we'll understand the question. So question is, find the probability that a leap year selected at random will contain 53 Wednesday. So in the question it is given that we have to find out the probability that any leap year that is selected at random will contain 53 Wednesdays. So as we know that in the leap year there are 52 weeks. So if we take this 52 weeks and if we multiply it by 7, we will get equal to 364. So in the leap year, as we know that there are 366 days. So it means there are 2 extra days in a leap year. So in any leap year there are 2 extra days. So now in the question it is given that out of these 2 extra days, one day should be Wednesday. So accordingly we have to find out the probability of that thing. So most importantly we have to find out the total number of favorable outcomes. So how to find out the total number of favorable outcomes? So as we see that out of these 2 days we need one day should be Wednesday. So it means the combination with the Wednesday will be that one day will be Tuesday and the next day will be Wednesday. Either this combination will work or if the first day will be Wednesday, then next day will be Thursday. So either this combination will work, because in both the cases we are getting at one Wednesday. So then only we can say, then only we will get the 53 Wednesdays in a leap year, because as we know that there are 52 weeks. So it means 52 Wednesdays are definitely there, but we need one more Wednesday in the year. And as we know that there are 2 extra days, so out of these 2 extra days we need one day should be Wednesday. So there are two total favorable outcomes in which we get Wednesdays on one day, on any one day out of these 2 extra days. So these 2 favorable outcomes are outcomes are that first day will be Tuesday and the next day will be Wednesday, or if the first day is Wednesday then the next day will be Thursday. So total number of favorable outcomes are 2, and total number of outcomes of possible outcomes, total number of possible outcomes will be 7. Now how 7 will see that if we not consider that out of these 2 days one day will be Wednesday, then apart from these 2 days can be any day. So if we consider that the first day will be Monday, then second day will be Tuesday. So this combination will also work. If first day will be Tuesday, then the next day will be Wednesday. In the same way, if the first day will be Wednesday, then next day will be Thursday. In the same way, if the first day will be Thursday, then next day will be Friday. In the same way, if the first day will be Friday, then next day will be Saturday. And in the same way, if first day will be Saturday, the next day will be Sunday. And the last is, if the first day will be Sunday, the next day will be Monday. So out of these are the 7 possible outcomes that we can get in case of 2 extra days. So these 2 extra days can be anything out of these 7 possible outcomes. But in the question asked that one day should be Wednesday. So out of these 7 possible outcomes, these 2 are our favorable outcomes. So it means the probability that a leap year have 53 Wednesdays will be equal to total number of favorable outcomes, that will be equal to 2, divided by total number of possible outcomes, that will be equal to 7. So this will be our probability of getting 53 Wednesdays in a particular leap year. So in this way we have to solve the question based on the leap year or the normal year. So accordingly, most importantly, we have to analyze the question properly. Now we'll see one more example based on these probabilities. First, write down the question. So question given as face card of diamonds are removed from a deck of 52 playing cards and is well shuffled. So this question is based on the playing cards that we normally use, that these playing cards contains different design of cards which includes diamond card, which include hearts, black heart cards. So these different type of cards or different designs of cards are there in the playing cards. So this question is based on them. So in this question, it is in the first information given is that the face card of diamonds are removed. So face card are J, Queen and King, because this contains faces. Face cards are which contains faces, and these are J, Queen and King. So there are 3 face cards in every design. So in particular design in the diamonds, it is said that these 3 face cards are removed and then the playing cards are well shuffled. So now the question given is one card is selected from the remaining cards. So find the probability, first probability of getting first heart, second king, third red face card, and fourth a diamond. So and accordingly in the question it is asked that one card is selected from the remaining cards. So as we know that if 3 face cards are removed, it means out of 52 3 cards are removed, that remaining number of cards will be equal to 49. If if the one card is selected at random from these 49 cards, so accordingly we have to find out the probability first of getting a heart. So as we know that the heart is of red color, and there are 13 cards of every design. So it means there are 13 heart cards in the remaining 49 playing cards, because the cards of diamonds are removed, not of hearts. So it means there are 13 heart cards are there in the remaining 49 cards. So it means the probability of getting heart card will be equal to total number of favorable outcomes. So now as there are 13 heart cards, so favorable outcomes will be 13, because out of these 13 we need any one heart card. So because one card is selected at random, so we need any one card out of these 13 cards. So it means there are total 13 favorable outcomes out of the total favorable outcomes which will be equal to 49, because now there are 49 cards remaining in the pack of playing cards, because 3 face cards of diamonds are already been removed. So that means probability of drawing a heart card will be equal to 13 by 49, that is our favorable outcomes divided by the total number of possible outcomes. So this will be the answer of the first part. Now in the second part it is given that if we select one card, that card should be the king. So as we know that 3 face cards are already been removed, so it means one king is already been removed, and in the playing of 52 cards we know that there are 4 kings. So if one king is already been removed, so it means there are 3 kings remaining. So it means the probability of getting king now will be equal to favorable outcomes divided by the possible outcome. Now the favorable outcomes will be 3 because one king is already been removed, and total number of possible outcomes, which will be again equal to 49 because now the 49 cards are remaining out of total 52 cards. So this will be the probability of the second part. So now the probability of getting red face card. So if we see in the 52 playing cards, there are 6 face cards, 6 red face cards and 6 black face cards. So in this the probability is given as probability of drawing a red face cards. So as we have seen in the information given in the question is that 3 face cards of diamonds are removed. Diamonds means generally in the language we say it as the eat ka patta. So 3 face cards of diamonds are removed. So it means, and diamond is of red color, it means 3 red face cards are already been removed out of 6 red face cards. So it means the remaining face cards will be equal to 3. So that will become our favorable outcomes because we need to select one face, we need to select one card out of these 3 remaining face cards. Because the question it is asked that we have to find out the probability of selecting a red face card. So now again our favorable outcomes will be 3 out of the total possible outcomes, which will again be equal to 49 because the total number of cards in the now is will be equal to 49 as 3 face cards of diamonds are already been removed. So the probability of drawing a red face card now will be equal to 3 by 49. And the last part, the question, it is asked as probability of getting a diamond. So as we see that out of this 13 diamond cards, 3 diamond cards are already been removed, which are also the face cards. So as 3 diamond cards are already been removed, so now the remaining diamond cards will be equal to 10. So this will become our favorable outcome because we need to find out the probability of drawing a diamond card, and this will again be equal to the total number of favorable outcomes divided by the total number of possible outcomes. And now the favorable outcomes in this case will be equal to 10 because there are 10 remaining diamond cards, and again the possible outcomes will be equal to 49. So probability of drawing a diamond card will be equal to 10 by 49. So in this way we have to actually analyze the question properly, and accordingly we have to solve by using again the same formula, that is the total number of favorable outcomes divided by total number of possible outcomes.